So let's see how it goes with the time. But summary is maybe the right word, because I mean, in a bit more than 10 minutes, of course, it is going to be quite rather summarizing work here. But anyway, the context of what we're working with here is that, of course, production in around Europe is done, for dairy or beef or dual-purpose cattle, is in quite different environmental conditions and geographical conditions. That's on the one side. Also, there's a quite different production systems that we are using to produce with these animals. So the GenTORE ambition was to provide tools and knowledge that promote to increase efficiency and resilience at the individual animal level, as well as on the system population level, and in particular also with a view of how it works at local environments. So, and in that context, and we want to use both the within breed but also a crossbreed variation in doing this. So it's not just a project for a particular high-level breed, it's really to see across the scale. So in trying to achieve this, we decided to work with some themes. And one theme you just saw well presented by Emra was genomic tool for systematic crossbreeding systems and more at mixed breeding systems. Genomic prediction across different environments. Genomic models for efficiency directly for the traits of efficiency and resilience. And also some management tools to let farmers decide, give them tools to decide the fate of the cows and the animals in the systems, how to make, in general, to give them a more efficient and resilient system. So, I mean, why do we think that crossbreeding comes into this? So, the thing with crossbreeding is, of course, that a farmer can choose, or you can combine strengths of different breeds to make the animal fit well the environmental conditions of the farm. So you can exploit this. So you may have a farmer with you need a high productivity, but you may want to quickly, add some more higher fertility, higher longevity to this breed. So we think that crossbreeding in a way can be used at a local scale in a way to accelerate the direction to this efficiency. And if you use a sexed semen, you can also add in, that you want to use to select for, to decide the fate of the cow. Do you want to have a replacement heifer, or do you want to produce some meat on the final and get a beef production on that? So then you may want to use beef on the dairy in that situation. So the thing is that prior to GenTORE, and in terms of really using these across, multi-breed, cross-breed, genomic evaluation, you need, in order to make these decisions as a farmer, you need these tools to say something about the genomics of the animal, and they were not really available. And Emra just gave a very nice presentation about that, so I can go a bit quickly. I think he underplayed maybe a little bit his own contribution, which was the first main paper that came up with the full model. And as Emra said, we have working with different kinds of ways to make them applicable for larger scale industry level applications. And we have worked with different systems. Anna is presenting, and Emma was much more exact. He knew the time and maybe the room even where Anna is going to give this presentation. I just know here that it's in session 25. But where she's going to show that in a real scenario, this model does give a very big improvement on the genomic prediction of the crossbreds. She's also going to show a little bit about why is it problematic in some scenarios. And she's going to give a little bit of insight as to the reason in the Nordic red, I think, why it was problematic, and using probabilities of breed variety of alleles rather than the absolute values. We have worked with rotational crossbreeding systems of Montpellier, Holstein, and Danish red, the friends are going to show results from this in session 2 of the World Congress. So you don't have to wait very long. It is the second talk, I think, of the Congress. As mentioned by Emra, a way to make this more applicable in larger systems was to be able to use the summary statistics for, and especially interesting if you have relatively few crossbreds and a huge populations of purebred animals that you want to bring in when you want to use still, crossbred and purebred information simultaneously. And I think that we can say software. I mean, Emra also, we have in context of GenTORE also just performed a training workshop, and what I hear so far is that it was very successful, and I think Emra, some softwares will also be available and sort of pipelines of how to analyze this whole thing. The other theme was D by E and models for analyzing genetic data across different environments. And of course, there are two sort of state-of-the-art. There are two sort of models that are usually used for that. Either we have multi-trait models where we have very categorical different environments, or sort of random regression model where you use sort of the trajectory of different environmental conditions. And in GenTORE, there was in a work package a lot of work in classifying different farm level, different kinds of environmental factors, different kinds of geographical and factors and so forth. And in the Bavarian Fleckli, we tried to use these factors in D by E models to predict genetics of different environments. And relatively limited D by E was observed. In another scenario, the French used either productivity or the hurdle levels as the environmental factor, and observed some G by E especially for I think clinical mastitis mainly. So for some of these disease traits, there may be strong G by E with the most extreme environments. So this will also be presented in the World Congress in session 27. So please go there and get some more information on the details. And not least, Interbul also made some work in multi-country evaluation of AIDS at slaughter, and it's all been implemented in the Interbul system. So the other thing was that we wanted to work with what if you have important QTL that have a different effect in different kind of environments, in different kind of extreme environments. So the Dutch were interested in being able to model sort of chains of covariances of the QTL over different environments. And we also wanted it to be able to use sort of standard software. So they came up with a protocol where you sort of split the analysis in two, and first you train the model in particular environments, and then you can use variances from these or SNP effects from these models to weight the SNPs in the final model in stage 2. So in the theoretic work, so with the simulated data, there was a slight improvement in genomic prediction for particular environments when you use this approach. And it's also used in a multi-breed analysis of the Irish breed, dairy and beef crosses. And there was some evidence of GBE. The genomic model worked well, but we didn't see an increase in actually using these heterogeneous SNP variances over the genome. And the state-of-the-art analysis of the FLECFI data is also ongoing with this model now, so we'll see in the end if that brings improvements. So now, of course, we also worked specifically with the efficiency traits, and in the growth efficiency you saw on some of the previous examples. Feed efficiency in dairy is, of course, a very hot topic because feed is sort of the biggest cost of producing milk, and it's important for economic and environmental sustainability. We worked on the back of work in the efficiency work package where Martin et al. Made this dynamic RFI model where you sort of use more the dynamic nature of the lactation, and this is also this is produced in animal, yeah. So the work here is mainly to add the genomic component to that, and as we know, feed intake is the limiting factor, so we're using multi-country data, mainly research farm data on the feed intake. And this work is also going to present it at the World Congress. Rasmus is going to present this model on novel genetic parameters to improve genomic RFI in dairy cattle using big data from multiple lactations and countries. In terms of resilience, I mean, the cows are met with challenges over the whole time, and a resilient cow can cope with these challenges and resume quickly to the production level. So we have basically two ways for looking at this in terms of genetics in the project. So first one is more like the local time, and on the short term. So Marieke Poppe is going to present this paper in session 27, where she's looking at different traits defined as to how the milk production deviates from an expected curve over time, and define traits to use as resilience traits for selection. The other way is to look at it more like an accumulated effect over the lifetime of the cow, and it's also based on work from the same work package. It's going well with the time here, right? And so what about the accumulated effects over the lifetime? And in the end, it was decided that functional longevity is really accumulating all of these effects over the time, but the information comes very late, and there are many component traits that contribute to this longevity, and the most important ones are disease traits and conformation traits as well. So the French came up with this two-step approach, one where we analyze the component traits with their most appropriate model, because the phenotypes are expressed very differently. And in the second step, we can combine those in a two-step, in a single-step, multi-trait single-step model to get the final result for resilience. And this is also presented in the World Congress here in session 2013. Management tools. Donna is not here, but there's been the thing is to look at now not only the genetics but all the information you have on the cows, and basically give tools to decide the fate of the cow. So should it be bred? Should it be culled? Should it be sold? And in particular, I have worked with 2 management indices. One for the cow to decide the fate of the cow in this context, and another one to set the value for beef as selling. Right. So this was very summaric, but here are the contributions, and ready for questions. Thank you. Is that okay?
Thank you, Mogens. So this talk is open for questions. We have a little more than 5 minutes, just 5 minutes. So is anybody who has a question?
We have one.
We have a microphone. And it works.
Oh, it works.
Eileen has a question.
For the recording.
Okay, I'll give in then. Mogens, you gave an example of why we need to look at crossbred in terms of beef cross dairy. Did you do any work looking at, at that in a real context where you're looking at sort of very classical meat traits in a crossbred beef cross dairy population? And, where there might have been alternative selection pressure in each of the sort of parent breeds, if you want, purebred breeds. Just if the traits are further apart from each other in both the parents, did you see different effects?
No, I think the thing is just that in terms of really the complementarity, you can use if you combine it with sex semen, you can have very extremely different on the parent breeds, but still in the end well expressed in the offspring, right? So we didn't do work. I mean, we did the work where we looked mainly at the beef traits, but in the beef and beef on dairy context combined, which was the work that Anna is going to present.
Any other questions? Yes, over here.
The SNP by breed interactions could be a genuine SNP by breed effect, or it could be just because of changes in LD between the SNP you're using and the causal variant. Your methods seem to be directed towards the assumption that it's just a local LD problem. Did you actually try and evaluate how big the SNP by breed interaction is, or the causal variant by breed interaction is?
Well, not the causal variant by breed, but I would say that, when it comes down to practicality, what is important is that the correlations are different, the LD are different, and there may be different reasons for that, but the models need to be able to cope with it, right? And this is why I think that the important addition of Emra's model was to really estimate the correlation between breed effects at the SNP level. You can do that in overall the genome, or you can do it single SNP, or you can do it in genome regions. So in that sense, you can use it to try and get a handle on are these correlations really different over the genome? Is it because in some regions they're sharing the same causal variants, and in some regions they're not? If we have the causal variants in there, you would be able to use those models to evaluate it directly. But in general, the thing is just that we don't have them, and we need to rely on the LD, and they are different between the different. But when we did I think generally, when we did the joint analysis and we have the crossbred information, the correlations was a little bit higher than what we expected, actually. They were generally, higher than, 0.7? Well, different from the different combinations, of course, but they were higher than expected from older analysis of where you only have the purebreds.